So we're going to start here taking a look at integration by parts. So what we need to do before that though is kind of take a step back and take a look at the product rule with derivatives. So as a quick reminder, our product rule is that when we have two functions u of x times v of x, we take the derivative of the first function times the second function plus the derivative of the second function times the first. So if we're looking at our example here, we've got x squared as our first function and natural log of x as our second function. So our derivative of this is going to be the derivative of that first function times our second, and then plus the derivative of the second function times the first. So we'll underline here with colors. There's our u prime, there's our u, and then we've got v and b prime right there. And, of course, I could leave it like this, but, as a mathematician, I just can't. I have to simplify it like that. So let me get that correct and have that be an addition. So I have to take that extra step. I can't help myself. So we know we have this rule. So let's take a look at what this means for us in terms of integration, because remember, integration is always that process of us going backwards to find our, we're starting with that derivative and we want to go back to figure out what function was it that we started with. So here we've got the integral of u times v prime and then v times u prime. So that is essentially what we have right up here with our product rule. Just we have the terms in reverse order, which is totally okay. We can switch those up. And if we had something that looked like this, where, it was something like this, or even, before we simplified here, that it was really obvious that we had gotten this from the product rule, we'd know that this was u times v. Well, this is not always what we have, but what we're going to do is use this property, the fact that this statement here is true, to help us get another way that we can find integrals. So we're going to rewrite this integral just a little bit. Oops. Sorry there, and getting a little ahead of myself if you know anything about integration by parts. So the first thing I'm going to do is take this integral that we have on the left-hand side and split it up as the integral of each piece. And then what I want to do is subtract this integral of v u prime dx from both sides. And this is part of the reason I wrote the terms in the order that I did. So this gives us the integral of u times v prime dx is equal to u times v minus the integral of v times u prime dx. This statement right here is actually integration by parts. It's not quite written how you're probably used to seeing integration by parts. If you've seen it before, you're probably used to it looking a little more like I have down here, where we've got u dv is equal to u times v minus v du. So this dv and du, kind of where does that come from? From up in this equation that we have up here. Well, let me underline things with a better pen here. Let me get a highlighter here. This dv is v prime dx. So where that comes from, let's grab a red pen. So u prime dx is equal to dv. This is really just saying that u prime is dv dx. V is some function of x, which we said it was way back up here. And dv over dx, that's the same. This is just different notations for the integral. And we've just rewritten it as v prime dx is equal to dv. So that's what we've done here in this sort of first part, is we've taken this v prime dx and replaced it with dv. And we did the same thing over here. We took that u prime dx and replaced it with du for the exact same reason, that we could write u prime dx is equal to dv, or du, excuse me, because u prime is equal to du over dx. That's just true. That's just notation that's true. So this formula that we have right here, this is our integration by parts formula. And it's a little sort of mysterious at first and kind of a little bit like, how are we going to use this? How is this going to help us? But we'll see. And once you get kind of a hang of what you're going to do with this, it's not so bad. So you may start to see the pattern as we go through these next couple of examples, but it may take a little bit longer with some more examples that we do in class. So we've got our theorem from our textbook, and I'm going to rewrite this down here just so that we have it in multiple places, because we're going to just refer back to it and refer back to it because it's a formula that we're going to use over and over again, and we need to, start making, getting our memorization of this done. So basically what we need to figure out when we're looking at an equation, an integral like we've got here, is we need to figure out what part is going to be the u and what part is going to be the dv. And we've got in our integral x times natural log of x dx. Well, what is going to be the u in this case? We are going to make natural log of x our u. And so that's going to leave our x and our dx to be our dv. So dv is going to include the dx as well. So remember back up here, dv is the integral of u times dx, and that's equal to dv. So I write that down here, that our u is equal to the natural log of x, and that dv is equal to the x and the dx. So now if we kind of go from, this is where we start, and here's what we need to get to. To get to this, we need u. We have that, u's right here. We also need v. Well, we don't have v, we have dv. So what we can do to this relationship that we have right here, our dv is equal to x dx, is that we can integrate both sides. Because why can't we do that? We of course can do that. And the right hand side, that looks like an integral that we've taken over and over again. That's 1/2 x squared. Over here on the left hand side, might help if we put a 1 in there, that we've got a 1 dv, and the integral of that, and our variable is v, is 1/2. So now we have that u is equal to natural log of x. So the u that's sitting right there is natural log of x. We now also have that v is equal to 1/2 x. There's v, and v is also right there inside of that integral that we end up with. The other thing that we need is we need this du right here. How we get that is from over here in our green relationship, we take the derivative of both sides of this. And you can do this as du dx, that's the derivative of the left-hand side. Derivative of the right-hand side is 1 over x. But what we want is not du dx, we want du. So we just need to multiply both sides by that dx. So now we have what du is equal to. It's equal to 1/2 dx. So let's go back over here and take our original integral, and let's grab that color. The integral of x, natural log of x dx, this is equal to, so again, it's going to be equal to u times v. So I will write them in here. So u is this natural log of x, so natural log of x, times v, that's our 1/2 x squared, and then minus, and I'll underline these in our colors too, after we get it written out. Then we have the integral of v, v is 1/2 x squared, and then du is our x, 1 over x dx, that is du. So 1 over x dx. So let's kind of label everything and make sure that it all sort of squares up with our formula there. So here is, nope, that's not u. This is u. Oops, sorry, my iPad kind of freaked out on me there. There's u, and u is also right here. So let's grab green, that's u, and that's u. And then we have v, and that's in a couple of places. Here's v, here's v. Let's grab blue for that, that's v and v. And then we have du, we underlined that in kind of reddish. There's du. Du is right here. So that is du. And if we also want our dv is right here, it's the x and that dx. Those guys together give us our, let's grab purple, dv. Now if we look at what we're left with in our integral, so after kind of getting everything in the place where it belongs, we've got the natural log of x times 1/2 x squared. That part of that integral is done. We can, write it in kind of an order that's a little bit nicer. And then this integral that we're left with, we have the integral of 1/2. And in here we have 1/2 x squared times 1 over x. That x squared cancels with our 1 over x and just leaves us with x. So we have 1/2 x dx. And now take a look at this integral that we have sitting right here. We know how to do that integral. We've done this property that we know is true because it comes from the product rule that we proved back in 251. And we now have an integral that we can take. So we get 1/2 x squared natural log of x minus 1/2 times 1/2 x squared, and then plus our c. So we get 1/2 x squared natural log of x minus 1/4 x squared plus c. So now remember, we can check these anytime. So remembering like way back from the beginning, what we found here is that this is our derivative right here. And then this is our original function that we start with. So if we take this function that we got as our answer and find its derivative, we should get back to where we started. So let's do our check here. So let's find the derivative of this function. Well, to do this first part right here, we have to use the product rule. We get 1/2 times 2x times the natural log of x plus 1/2 x squared times 1 over x, and then minus 1/4 times 2x, and then the integral of c is 0. So let's take a look at what we've got here. These 2's cancel and leave us with x natural log of x. And then over here, that x squared on the top cancels with that 1x that's on the bottom. So we're left with plus 1/2 x. And then minus, in our last term, we've got a 4 there and a 2 there, so that leaves us with a 1/2. And so we've got 1/2 x, and then we've got plus or minus, and those two guys cancel, and we're left exactly with what we took the integral of. I'm going to do one more example of this in our next video.